Okay, we're looking here at the integration by parts technique, and we want to see if we can apply it to this integral here of the secant cubed of theta d theta. And again, if we're confronted with an integral, we don't see an obvious solution, the first step should be, can it be solved with a u/du substitution? Clearly, in the form that this is in, that's not going to be amenable to that. What happens if we try to rewrite it then, like this, 1 plus the tangent squared of theta times the secant of theta d theta. If we say, well, if I say let 1 plus the tangent squared of theta be equal to u, du would equal 2 times the tangent of theta times the secant squared of theta. That substitution won't work. If I say let u equal this, du would be the secant of theta times the tangent of theta. That substitution won't work. What happens if we just multiply it out? Here we would get the integral of the secant of theta d theta. That we know how to do. And then here, plus the integral of the tangent squared of theta, secant theta d theta. And this we cannot use doesn't look like we can use a u/du substitution on this, because if I say call this u is the tangent of theta, du is given the secant squared of theta, and here if we say let u equal the secant of theta, du would be the secant of theta times the tangent of theta d theta. That's not going to work. And you might be tempted to say, well, wait a minute here. The tangent of theta, that's the secant squared of theta minus 1. That's not really going to get us anywhere, because here we're just going to go around in circles at this point. If you don't believe me, we'll multiply it out. Here we would have the integral of the secant cubed of theta minus the integral, substituting this for the tangent squared, secant cubed of theta minus the integral of secant of theta d theta. Bring this over to here, that subtracts out to 0, and these add up to 0, so at this point we're just going around in circles. So it looks like this isn't going to work, and no u/du substitution seems to help us out. So let's go back to where we started. Integral secant cubed of theta d theta, and try using our integration by parts method. Now, it might be tempting to say, well, what happens if we just call this dv? If we do that, then of course we have to call this u, which means we have to differentiate that. It's not a problem, we can do that easily. And this we can integrate easily to get v. But remember now, when we're setting these problems up, we're going to get an integral not of u dv, but of v du. And we have to try to do it in such a way that this integral can be solved, whereas this one here we cannot solve. So if we try put like this, dv, or v is just equal to theta, no problem there, but du is going to be 3 times the secant squared of theta times the derivative of what's inside, which is the secant of theta times the tangent of theta d theta. So now when we have our integral of v du, forget the uv part for now, we're going to be taking the integral of theta times the secant cubed of theta times the tangent of theta. Looks much more complicated than what we started off with. So that's not going to get us very far. Before we rewrite it using any trig substitutions, what happens if we just did this? We had the secant cube theta d theta, and so far we've just encountered a bunch of dead ends. Write it like this though. The secant squared of theta times the secant theta d theta. Okay, let's try this. Now, again, if we're going to use this form of it and try to work with it, we have to choose what do we want to call u, what do we want to call dv, and here, as we're making that decision, not only do we have to be cognizant of what we call dv, we have to be able to integrate to get v, but when we form this new integral here, we want it to be less complicated than our original integral, not more complicated. So if we look at this and we say, well, what about this here? If we call this dv, we know what the integral of that is. V would be equal to the natural log of secant of theta plus the tangent of theta. And if I was doing this problem, I would stop right here, because we have to think of one step ahead. Here we're going to have to take the differential of that to get du. But here our integral here is going to be v du, so I'm going to have the integral of this times more things. At that point I would just stop and give up. I think that is an unwise choice. So that means then we call the secant of theta u, and this would be dv. If dv, well, let's just write things out now. If we said we're going to let u equal secant of theta, du is the secant of theta times the tangent of theta d theta, and dv is the secant squared of theta d theta. V is just the tangent of theta. So this looks like it might be the most promising way yet. So here we're going to have the integral of secant cube theta d theta equals u times v, so we'll have the secant of theta times the tangent of theta minus the integral of v du, tangent squared theta times the secant of theta d theta. Now, this might look familiar to you, though. We had this integral back when we rewrote this here as tangent squared theta plus 1 and multiplied it out. That didn't work for us, but this time we have a minus sign by this integral. So let's try this. The tangent squared of theta, that is the secant squared of theta minus 1. So now how do things play out? Here we have equals, this is unchanged of course, minus multiplying here. Now we have minus the secant cubed theta d theta, and then minus 1 times minus 1 is plus 1, plus the integral of the secant of theta d theta equals the integral of the secant cubed theta d theta. Before, when we tried this substitution up here and multiplied out, we had these two integrals, but now this one here at the secant cube, that has a minus sign instead of a plus sign. So we bring it over here. Now we have 2 times the integral of the secant cube theta d theta equals secant theta tangent of theta plus the integral of this, which we know what that is. That's the natural log of secant of theta plus tangent of theta. And it looks like we should be finished. Multiply both sides by 1/2. Add our arbitrary constant of integration, and there it is. That should be the solution. So again, we played around with this a little bit. We tried different ways to see if we could make a U to U substitution work. We tried fooling around, trying to decide what we should call U, what we should call dv, what's a wise choice and what's an unwise choice. And finally we got it into this form here, and this integral here we encountered before just by doing the substitution. The difference is it has a minus sign here. So that when we break this apart with our trig substitution here, we get minus the secant cubed of theta, whereas up here we had, so here we have the integral of the secant cubed of theta on this side, minus it on this side. Over here we had equals this, plus on the other side of the equation we had the positive integral of the secant cubed of theta. Thetas cancel out, but here when we do it by parts, they do not cancel out. It gets 2 times that over here, so we get 1/2 in our final expression. So this time the integration of parts works, but nothing else appeared to work. Now here we have a sort of a complicated expression for this. If indeed this is correct, if we take the differential of this expression, we should get the secant cubed of theta d theta. And I don't think we'll have enough time in this video. Come back and join us in the next video. Let's take this differential here and see if we can prove that we have the correct answer.